Our next speaker is Oleksii Pilkevych. I've met Oleksii a while ago on Nokia Toastmasters meetings, and at first he seems a little bit creepy, but to tell you the truth, he is a very nice guy, and he inspired me not to do certain things in life because I don't hate myself. Please welcome Oleksii Pilkevych with his speech, "Hate yourself, keep using Python 2." Hate yourself, keep using Python 2, Oleksii Pilkevych.
Hello? Okay. Huge thanks to Jarek for this introduction. I once did a talk about pornography on Wroclaw Toastmasters, and it was very inspirational for Jarek, as he mentioned. This talk is kind of a big deal. I have a lot of friends here, both watching me on the stream and sitting right here. I have my parents. It's my father's birthday. And as for my mom, she doesn't really do programming, but if I say something stupid, she will just know somehow. So I have to be really careful. As for what you are currently observing on the screen, do you feel anxious? Do you feel fear when you are looking at it? Something terrible is going to happen in 1 month and 11 days. As you may have heard, it's the end of life for Python 2. According to a survey conducted by JetBrains, only 13% of people are still using Python 2. Those people on this sinking ship that is about to burn and explode. How many of those people are sitting here currently? About 13%. That's very accurate. I used to be on that sinking ship as well, but not anymore. Not because I migrated successfully, but because I changed my job. That's recommended as a fastest method for moving to better technologies. Right now I work in Perceptics, where we are trying to build a system for large-scale employee surveys. So what will happen if you do not upgrade in 1 month? According to Python documentation, if people find catastrophic security problems in Python 2, then most volunteers will not help fix them. Some of these problems will start on January 1st. Other problems will grow over time. Now that sounds very, very gloomy, especially in comparison to what people in Python thought when they were writing Python 3. Turns out some developers hoped that the community would do what Python did and do one last release for Python 2 and then jump onto Python 3, which didn't happen, as you have probably noticed during the last 10 years. So while I no longer use Python 3, I still feel an obligation to talk about this issue while it's still popular somehow. This talk is not a tutorial on migrating to Python 3, but more of a desperate cry of my soul for my brothers and sisters who were left on that ship written in Python 2. Maybe what I speak about today will help them find motivation, reasons, and tools for migrating to Python 3, and maybe it will help them convince their managers to do so. So as we see here, we have a very valid reason to migrate to Python 3. Or do we? Because there's a lot of legacy software in the world which still works. Banks are running in COBOL, and companies are still making a lot of money with legacy software. And Python 2 is not going to magically stop working on January 1st. It will still last for a long time. So what other reasons do we have? Maybe speed is another reason. Luckily, I found an article where somebody did benchmarking. And here we can see a graph. As you can see, Python 2 is really slow, and Python 3 is really fast. Or is it? Because if you look closely, those are some other Python distributions, and in fact, Python 3 is here. And as you can see, it's just a little bit faster than Python 2.7. And here they are benchmarking rendering HTML templates. But if we scroll down, they have a few more benchmarks where they do startup time. Turns out Python 2 is faster. On cryptography, also Python 2 is faster than on algorithms. Python 3 is faster. And if you scroll down, you notice that there's not much difference. Now, it would be a lie to say that Python 3 doesn't improve speed. As I read in an interview with Instagram developers, when they migrated Instagram to Python 3, they had 12% CPU savings and 30% memory savings. But it's still not this huge speed improvement like you get when you upgrade very old legacy systems. So maybe there are some awesome features, some vital differences that we need to know about to migrate to Python 3. Here is a list of links I found when I Googled Python 2 versus Python 3. And let's suppose I know nothing about Python 3. Maybe I'm a manager of a developer team, and I want to know whether it's worth to migrate to Python 3 or not. So we open the first article, and we see a user-friendly chart. Python 2 is legacy, and Python 3 is future. We kind of knew that. Old libraries built for Python 2 are not forward compatible. New libraries for Python 3 are not backward compatible. Makes sense. Now here we have ASCII in Python 2, and we have Unicode in Python 3. Well, luckily we have more characters to use. Maybe we can internationalize our application if we want to. But usually we do not, at least in my cases. We have improvements when it comes to division. Looks like Python 2 didn't know how to divide correctly. In fact, it did. You just had to use floating point numbers. So it's not like a super cool new feature. It's just a syntax change, which makes sense, but still is just a syntax change. And then you have the most vital part, the print function. What else do we have here? Well, spoiler alert, we don't have anything else. Oh, we have, why does Instagram and Facebook use Python 3? Because the ease of using Python and stuff like that, which we still had in Python 2. Maybe this article will help us. OK, so here we have division. Oh, the print function. See, we have to use parentheses, and in Python 2 we could write something like this. Oh, division again. Unicode. X-range. Oh, this is also very important. In Python 2, you would write xrange, and in Python 3, to get the same thing, you have to write range. Well, the rest of those features are similar. Here's another one. This one is actually one of my favorite ones. It has this section. Why should you use Python 3? Python 3 supports modern technologies like AI, machine learning, and data science. Never did, now supports. Supported by Python developers community. Too bad Python 2 was unsupported. Easier to learn, maybe a little bit, but not much. Offers libraries. Mixable with other languages. You probably get the point. I could do this all day. Here we have print function and division mixed. So what? Let's migrate. Let's devote a couple of months or more of our precious developers' time to migrate to this magic new language, which has support, libraries, and the new print function. Or not. I will digress a little bit before we jump into technical details, just to show you what mindset I would like to approach this with, and why the mindset we usually approach it with is kind of wrong, because it's the mindset we just witnessed earlier. Has anyone here read this book? 2 people? Or, yeah, 3, 4. Cool. This book is the most popular thing Mark Manson did, and while I'm not a very, very huge fan of this particular book, I'm a huge fan of his articles. And one of his recent articles is called, "If Self-Discipline Feels Difficult, Then You're Doing It Wrong." And it might be helpful for us, because migrating to a new version of a language is a problem of discipline a little bit. We have to stop procrastinating and start doing it. So what Mark talks about it in this article is he starts with a story where in his young years he tried something called Uberman sleep schedule. The idea was that somebody in the Navy noticed that whenever you sleep, 80% of your resting comes from 20% of your sleep. And if you lead yourself to sleep deprivation, then you could go to sleep and your body would automatically trigger itself into this resting phase. And then you could wake up right after the resting phase and not waste your time sleeping. But in order to start reaping the benefits of the schedule, you had to condition yourself first for 2 weeks. So for 2 weeks, you would have to sleep for 20 minutes, then function for 4 hours, and then repeat that until you get used to it. And that's what Mark tried to do, but he would always fail after 4 days. And the reason he would fail was, first, it didn't work. Second, he didn't get any immediate benefits from it. He would only get fatigue. So basically, the only thing he was running on was discipline and was willpower. And willpower is not enough for something like this. He sums it up really well in this sentence. You can will yourself to go to the gym if you don't feel like it for a few days, but unless the gym ends up feeling good in some way, you will eventually lose motivation, run out of willpower, and stop going. So first of all, we need a strong reason to do it, and second of all, we need to find something pleasurable in the process, otherwise we are going to fail. And I think this applies in software a little bit. The first time I noticed it was during this process. So what happened? I was in a project where we were developing Python libraries. At that moment, we didn't have a huge workload, and a new person was joining our team. So we thought, it's a great idea to write unit tests because we don't have any, and we have no idea how you write unit tests. So we had a lot of willpower and resources to cover our libraries with tests. So this was our strategy. If you've been here for the talk before, where Brandon was talking about bad Python practices, this is exactly what we used. The strategy was we find a random method, then we mock everything, every call to other method, other library. We assert which methods it calls, we assert what it returns, we have our test, and then we repeat it until all the code is covered. But unfortunately, the result was tests were basically repeating our library code. So whenever you had to do a change in the library, you would also have to change your test. Now you have 2 times more work when you are developing. And the funniest part was we had a library and another library that was using the first one. The first one was SSH, and the second one was some implementation for something. Both libraries were completely unit tested. But when the code was deployed, it didn't work because everything was mocked and they didn't integrate. The API of the SSH library changed. So not only did tests increase our workload, they also didn't notice bugs in places where they actually happened. So was there a better approach? I found a better approach. When I moved to another project, it had other challenges. We had a huge web application that would consist of many, many parts. And I got my first task, which looked like this. This application would monitor remote systems. And one such system had some kind of front end where you could do something as a user, and your task was to trigger a notification. And then our system that was monitoring it had to notice that notification, put it into the database, and display on its front end. So there you have the monitoring application, which runs in a Docker container. And by the way, there are very many systems that are monitored. So there are like 600 Docker containers and 600 monitored systems. And then all those Docker containers send data to another container which runs Django and has access to the database. And then another container with AngularJS would fetch data from the database and display it on our front end. So basically, the data had to travel through those 4 points. And as I was developing the code, I had to observe all 4 points simultaneously to see where a bug happens. So I literally had 3 monitors in front of me. On each monitor, I had one web page for the system front end, logs from the Docker container, logs from Django, our front end. I would click a button here, and then I would, in real time, observe what happens in the logs. Now, if you develop in such a way for a long time, it gets really, really annoying. You cannot even use one monitor for YouTube. So there had to be a better way. And there was a better way. A better way was just to mock the output to the monitored system, see if the monitor parses the data correctly, if it handles edge cases correctly, and if it sends data to Django. Then on the Django side, use Python Django extension and test whether the correct things are created in the database, and then use tests for our API and our front end to see if it renders correctly in the web browser, which we already had. Since I started using that approach, I could start developing features without even running the application itself. I would just write the tests, write the feature, then run the application once in the end, and it would usually work without any problems. So as you can see, I wasn't writing unit tests because I had to, or because I expected some benefit a year from now. I was getting benefits right away. And this was reducing my pain. And that's why it worked. Can we use it for Python 3? The answer is yes, we can. The problem is that because we read articles like I showed you before, we do not know what we are actually trading by not migrating to Python 3. We don't know that actually we are in huge pain because those articles do not mention it. This is reason number one. At first I was wondering if using the word suck is appropriate for such conference, but then I remembered what tracebacks look like in Python 2 and decided that it was actually fine. So here's what I'm talking about. You have some code. Say you bought a smart fridge. You can open it, and the only method it can execute is sing a song. For those of you who don't know, a context manager lets us create this object and clean up its resources after we exit this block. And in order to use this syntax, we have to implement enter and exit methods. So as you can see, this code is pretty harmless. It even says so. It imports some very harmless things. And actually, you can't see what this code is doing because it's all wrapped in this stuff that is imported. So let's say you run it with Python 2. Where am I? So here you have Python 2, and you run your code, and oh, there is an exception. Where does it come from? Let's look at the traceback. In fact, tracebacks are vital. They're supposed to help us. So they shouldn't look like they do in Java, but they should give us the points of what's happening line by line and where our exception happens. So we see that something happens when we sing a song here in this place. And we also see that there is a print statement here, and we don't see it in the traceback. But then we see the traceback leads us here. Typical cleanup function, which is not executed, right? Because let's think, we're doing this with statement, which is firing the enter method. Then somehow we executed sing a song. So this thing here was returned already. And then here we see this in the traceback. We're not getting the print statement. So it failed here. How could it get to this place? This is very strange. But after a little bit of debugging, we are going to enter the typical cleanup function, which is here, and we find the error. So apparently, somehow our code got to this place without executing this, and this exception fired. So let's comment it out. Run it again, and we see another exception, which leads us to sing a song, some harmless function. It didn't lead us here before. If we enter it, we see that it raises an exception. This problem happened before, but we didn't know about it. But what if we run it with Python 3? the traceback is a little bit longer. And surprise, surprise, actually readable. We try to sing a song, some harmless function happens, raises an exception. Then while we try to handle this exception, another exception happens. And by trying to handle this exception, I mean we go to the exit part of the context manager, because that is where you handle exceptions in the context manager. And while we're trying to do that, this function gives us another exception. Makes total sense. If you think that this is not a big deal, I once spent half an hour or an hour debugging something like this, because our application was more complex than this fridge, and in fact, I didn't even remember that the code I was debugging was inside of a context manager. I had no idea where the exceptions are coming from. And in fact, I had two of my coworkers ask me to help them debug an issue because they didn't understand what an exception meant. And instead of helping them, I just said, try running it on Python 3, and the problem was solved in 2 minutes. That might be an argument for managers. The most precious thing we have, developers' time, is being wasted because we are not using tools that are there for us. Another thing about exceptions is this. Raise your hand if you have seen this abomination in your code base. 1, 2, 3 people. Still some. I saw this in 2 projects. Does anybody know what this is supposed to do? I had no idea. It looks like this thing doesn't do anything at all. You have a custom exception that inherits from base exception and has a method raise with traceback. First question is, are there any exceptions in Python that are raised without tracebacks? And in fact, this syntax here makes no sense. When I was preparing this presentation, I didn't even bother to check what this does, because this is some code copied from Stack Overflow. It was in our repositories, and nobody knew why it was working or what it was doing. But after some research, you see this. Here is a problem. You are a good developer, and you want to catch low-level exceptions and raise your custom exceptions so that your user knows what went wrong. In this example, let's say you have some configuration that you want to remove. And you have to remove it from a dictionary and then remove it from the file system. And while you are doing that, those errors can happen. So you are catching those, and instead you are throwing your own error so that somebody on the top could intercept it. The only problem is when you run this code in Python 2, this is everything you see. And if this happens somewhere in production environment and you have to debug it from the logs and you didn't expect it to happen, you have no idea why it happened. On the other hand, if you run it in Python 3, you see the traceback, which shows you that it failed on this stage and not on this stage. We have the exact same message. In fact, if we wanted to make it even more readable, we could use this syntax, which comes to us from Python 3. In this case, we see that this behavior was not accidental, but it was planned, because the message changes from during handling the above exception to the above exception was the direct cause of the following exception. Let's say we wanted to have something like this in Python 2. That's when our base error comes in. This is how we can run something like this in Python 2. We make our custom exception inherit the base error, and then instead of raising it normally, we raise it using this ugly syntax. But the problem is not just the ugly syntax, the problem is that it doesn't work like it does in Python 3. We see this delete cache configuration line, but the traceback is shorter and it is not as verbose and readable as it was in Python 3. And if we try to run it with Python 3, it actually doesn't work because the syntax is deprecated. So what if we want to run it in Python 3? We use compatibility modules. And our code starts to look like this. We import race with traceback from future, and then use a slightly less ugly syntax. But spoiler alert, in Python 2 we are still going to get this short traceback which doesn't give us as much information. So really, there is no escape, and even if you try, you write ugly code and reap only part of the benefits. And this was only mentioned in one article on the first page of Google search I did. For me, this was one of the most vital reasons to migrate to Python 3. Now let's move on to inheritance. And with this one, I would like to do something crazy. How about migrating Python 3 code to Python 2? We have some simple code here. We have a car. This is Python 3. We have a car, and we have a race car, which inherits car and overrides start method to do something before it. So in pure Python 3, it looks something like this. The code is so clean, it doesn't even seem like anything is happening at all. We run it. Race car prepares nitro. Our car starts the engine. Everything works. Now let's try running it in Python 2. Okay. Super doesn't work. It doesn't work because in Python 2 by default we have old style classes and we have to inherit object. And you have to remember to do this all the time whenever you try to use inheritance. And if somebody thinks they don't have to do it in Python 2, but then somebody else has to reuse their code with actual inheritance, you have to write workarounds to make that class actually inherit object and start behaving like new style class and start using super. Let's try running it now. Super takes at least one argument. Okay, so that one argument is probably self. Oh, no, this argument must be type, not race car. Aha, so self is a race car, but here we need a type. And a race car is a type. Okay, so we can understand that probably this is what we need. And then we get another error. Eventually, we Google how to use super, or we use our IDE to help us, and we end up with something like this. After a few years of programming in Python 2, I still don't remember which arguments super accepts. Maybe somebody can empathize with me. This has always been filled out by the IDE for me. Now finally it started working. But let's say we wanted to extend this code. Let's say we want to have a flying race car. So we create another class that inherits race car, and here we are Spreading wings. Looks good. This is our code. Let's run it. For some reason, we didn't spread our wings. Not only didn't we do it, but we also didn't notice that we didn't do it. And that's because we forgot to modify this. We had to put flying race car in here, and now it's working. For some reason, it's not. Aha. Yep. Yep, it's a little bit different. So it's not working in another way. We are spreading our wings, but we are running super for race car, which resolves to this. And so we are skipping the prepare this part, right? And we do not notice it. So once we modify this part, everything is working correctly, but we have to notice it. Now, what if we run it with Python 3? It still works in Python 3, but the code can be simpler. We do not need object. We do not need this stuff in super. And spoiler alert, because we do not need it, there is no chance an error like this happens in Python 3. If you want your customized super, you can still use it. But if you don't, your code is cleaner and a chance of errors is much smaller. This is another problem with Python 2. And in fact, with Python 3 as well, we have no idea what the hell str means. It's a type that is supposed to represent text. But it's not what it does. According to Python 2, str contains bytes, which probably are convertible to ASCII. So if you ask it, it will probably succeed, and you will probably have text. But if you want to be sure that you have text in Python 2, you are encouraged to use Unicode, which means you have to put a small U letter before your strings, or convert your strings to Unicode explicitly, which nobody does. In Python 3, you have Unicode by default in literals, and str represents bytes. No, str represents only strings in Python 3, and bytes represent bytes, like they are supposed to. But this creates tremendous issues during migrations. Here's why. This is a case we actually had in one of our projects because we were using a lot of SSH to interface with other systems. Here we have some code that creates an SSH client, connects to a remote server, lists files and directories, reads the data, searches it with a regex, and prints it on the screen. Let's hope internet is working, because if it is not, it does. So we are getting our data. Now let's run it with Python 3. We get an exception. And this exception happens because we are trying to fire a regex search on bytes, not on strings. So apparently this has to be converted to a string. in Python 3. Now it is going to work correctly. And this thing is not going to change anything in Python 2, because in Python 2 you're converting bytes to bytes. But in this case, our regex worked differently for some reason, and we have to understand why, because now we are getting a different output in Python 3. Now this is a larger discussion. A talk about Unicode would take far more than an hour. But the real danger here is that whenever we are trying to migrate code, we get this advice. Get some tools that check your syntax and put them into your CI, and you will know if your code is Python 3 compatible. That's what was happening in our project. We had tools that told us that our code is Python 3 compatible, which it wasn't, because those tools couldn't check which types we are receiving from SSH and how this stuff behaves. Another problem we faced was type checks. We were running tests in Robot Framework, and Robot Framework has this thing where whenever you pass arguments to functions, even if you type a number, it is converted to a string. It is interpreted as a string. So in Python, if you expect an integer, you have to first convert it to an integer. But what many people were doing is they were checking types. So let's say you want to know if something is a string in Python. And just by asking that simple question, you are already getting into a lot of trouble. Let's see if this code works. We want to print cot if it's a string, and print not a string if it's not a string. This is a string, this is not a string. Works well. But what if we pass Unicode? In fact, Unicode is a string, right? Turns out it is not, because in Python 2 it's another type. So we have to run something like this. And it works in Python too. But as you probably can see by this red line over here, it doesn't work in Python 3, because you do not have such type. You do not need Unicode. So in this case, you would want to check something like this. You would have to check if this is str and if this is bytes. And then it would work in Python 3. But spoiler alert, it doesn't work in Python 2 anymore. So we have to do something like this. We have to use future. And here an interesting thing happens. You import str from future, and now suddenly the built-in Python 2 str starts working differently. Instead of converting stuff to bytes, it now converts stuff to Unicode. And if you have a long script, which we did have, and we used a lot of stuff from future, I noticed that at a certain point, I had no idea whether the current str I am using is converting stuff to bytes or if it converts stuff to Unicode, which made our life even harder. And also, in this case, here is another issue. Let's say you want to document this variable. You want to tell other programmers which type is expected. And you say str, and you have no idea what it is. So suddenly, your interpreter in Python 3 tells you that this is not what it expects, which is the correct thing to do. It's actually helpful. But if you change your default interpreter in your IDE to Python 2, this is what you are getting. Expected str got Unicode, and PyCharm doesn't notice that we are importing str from future. So because of stuff like this, documenting Python code became much more difficult because nobody knows how strings look anymore. So what we ended up doing was we would just document it like this and make our IDE ignore it, just not to flood us with unnecessary warnings. This is a picture I found somewhere on the internet, which actually explains what decode and encode methods do, which, to be fair, in our code base, we would use randomly just to make the bad words disappear from the screen. Another issue is imports work in Python 2 in a very unpredictable manner. And even after a few years of writing heavily in Python, I still have problems with imports every couple of months because I forget how they work and what they import. Here is the problem with Python 2. Let's say you have a project that looks like this. You have a main script which imports a module from script from this module. This is the script it imports. This script, on the other hand, imports common. The question is, which common does it import? This one or this one? If you import the global common, which is in the root directory, this is what you are going to get on the screen, imported global common. If you import the local one, you are going to get imported local common. So which one are you going to get? The answer is, it depends. If you run this with Python 2, you are going to import the local module. Which means this one. But if you run it with Python 3, you're going to import the global one. Question is, which one do you want to import? Let's say I'm on Python 3, and I decide that actually here I wanted to import this module. The solution is simple. I just write from dot import common, which means import common from this local package in here. And now suddenly, now I'm importing local module. What can I do in Python 2? Because in Python 2, with this code, I'm getting the same local module. And without this code, I'm getting the local module as I did before. What if I want to import the global one? The answer is you have to use from future import absolute import. Because by default, Python 2 cannot do something like this. Now this thing I'm especially proud of. Probably you are not going to experience this case yourself. It was a huge coincidence that we experienced it. I was conducting a TDD workshop based on training materials by Grzegorz Latuszek, who performed on Code Dive a year ago. And this was the idea. We had a spaceship. We wanted to show people that writing tests before writing code actually helps you in the long run. So this is the code. We have a spaceship that receives a direction in it. Directions are labeled as north, south, east, or west. If we want to turn left, it changes its direction. If we want to turn right, it also changes its direction. Then we had tests. Those tests were written in PyTest. We have a fixture which returns us an instance of a spaceship that is directed north. Then we test if it turns left correctly. We test if it turns right correctly. First of all, we enter a direction, then we turn left, then we check if the direction looks as expected. For example, if the ship is pointed north, once it turns left, it has to be pointed west. And that's what all of this code does. Now, what we did after that was we decided, what if we want to change the implementation but preserve the API? The idea was we wanted to optimize our turn left and turn right methods, and we wanted the spaceship to operate on actual angles and not on dictionary mappings. But in those tests and in the non-existent supposed client code, we were using directions. We were set in a direction, we were checking a direction. And we wanted to show the power of Python properties, because we can conceal the implementation behind the property. So here we have a mapping of directions to angles and angles to directions. And here we are concealing our implementation and reaping the benefits of turning using angles. The problem was, the whole idea of this exercise was to observe other people writing code and just guiding them. So I had someone from our training sitting there rewriting this code to this code. And this person forgot to write the setter. He only wrote this property. So the idea is that what happens now, whenever we try to set the direction in our test, in this place, something should happen, because we do not have a setter. It shouldn't succeed. Let's see what our tests look like. In the original spaceship, we could run PyTest with Python 2, and our tests would pass. But in the new spaceship, we would run those same tests, and they would fail while comparing directions. Why are they comparing directions? We cannot set directions, we do not have setters. And that was the problem, because I expected to get another exception. In fact, I expected to get an exception that I would get if I ran this code with Python 3. Can't set attribute, because you don't have a setter. And once you have this setter, tests work in Python 3, but they do not work in Python 2. And why is that? Well, that's because apparently there is some bug in PyTest in Python 2. And when you have this fixture and you assign to direction, you do not actually execute the setter, you overwrite the attribute. And this is something we found accidentally because another person on the workshop said that everything is working correctly. Turned out that that guy was just running his code with Python 3. Now, there are many more features which are kind of cute in Python 3 and should boost your motivations to migrate. Those features are type annotations. Instead of writing something like this, flooding your code with useless docstrings, you can do something like this and have type hints. instead of writing classes like this, you can write data classes. You wouldn't have to implement methods like equality and hashing. Instead of flooding your code with arguments for format, you can use f-strings and have a very readable and compact code. You can use keyword-only arguments. This is something crucial. If you want to forbid your users from entering arguments positionally, you can force them to enter arguments only by their names, so that this line would fail only if you put a star here. And now you magically forced all your users to write code that is readable. And also, if, for example, in this case, you want to add database username and database password, which are optional, you can do something like this. Your code is not going to fail. This line still works. Now, I could talk about features all day, but question is, how do we actually migrate? This is how we migrate. It's not actually a huge rocket science. If you Google it, you will have a lot of tips and tricks. You have packages from Future that help you convert your code automatically or use some compatibility features to make the transition smoother. But the thing is, it depends on your project. Question to Jarek, do we have 5 more minutes?
Yes, we do.
Cool. So I had 2 cases. The first one was the project with libraries. The second one was the project with the web application. Here is a little diagram of how it worked with the libraries. This is what our system looked like. So we had a huge central server that had all the libraries installed, and it had Python 2 interpreter. The testers were writing tests in Robot Framework, and they were sending those tests to the server, which was executing them. The problem was, we wanted to migrate from Python 2 to Python 3. The good part was that most of those libraries were really trivial. They were only using SSH, a little bit of database, HTTP requests, SOAP requests sometimes. Migrating it to Python 3 wouldn't take a lot of time. And in fact, there was a team that started this huge migration process. And they contacted all developers and told us, please make sure your code is Python 3 compatible. And we thought, yay, we're getting to Python 3. So we made our code Python 3 compatible. We faced all the pain regarding Unicode, which I showed you earlier, but the migration wasn't happening. We were asking the guys, how's it going? And they were saying, well, it's going slowly because other teams are not migrating for some reason. In fact, those testers who are sending the tests to the server can attach little Python scripts to those tests. And we had no idea how those scripts were written because they weren't even checked by CI. So at this point, this migration became almost impossible. And in a month or 2, turned out our libraries were not actually Python 3 compatible because we stopped checking compatibility. This project is still in Python 2, and I have no idea how it is possible for it to migrate to Python 3 unless all the teams cooperate. This was case 2, the application for monitoring remote systems. The good part about it was each application was separated into its own Docker container, so it didn't really depend on other applications, and you had complete control over your interpreter. The problem was the stack was a lot more complicated. We were using Django, Django channels, Twisted, Django REST framework, and more. So we had to adapt. But at least we could start taking it bit by bit. And what I actually did was I migrated an application to Python 3. The task of that application was managing Docker containers. So it would receive requests via WebSockets, and it would have to either start a container or remove a container. And also it would have to notice whether it is in Docker Swarm mode. If it was, it would create and remove services, not containers. So the good part about this application is it had only a few use cases. So you could easily cover it with tests. I added tests that check whether a container is created, whether it is updated, whether it is deleted. Same things for services, assertion whether statuses are sent to backend. The only challenge was I had to test it on real containers and services, not mocks, because I had no guarantee what this stuff behaves like in Python 3. Once I did it, migration to Python 3 took 10 minutes. Here are some other lessons. Since we are running out of time, I encourage you to Google how Pinterest and Instagram migrated their code bases to Python 3. If you look at those slides, they're really nothing very revolutionary in this case. Upgrade dependencies, make your code compatible, test, migrate production to Python 3, remove rubbish for Python 2. They also had some interesting cases with Unicode, which there are plenty of. This is how you would summarize tips from Pinterest. Using Futurize, the interesting thing was that they were running an automatic tool for fixing their code, but they would run it one fix at a time. So for example, they would migrate all their syntax for print functions, and then they would commit it, and you would have a diff for that single fix. So you didn't have huge diffs where you do not know what's going on. Of course, they had unit tests, and they had to separate them in a sensible manner, because a lot of code is Python 3 incompatible, and their test wouldn't run if they had it all coupled. In case of Instagram, they also used the approach with small diffs. In fact, as they say in this talk on YouTube, which I encourage you to watch, they didn't use branches. They would throw everything into master. Of course, those commits they were throwing into masters had to be checked really well. But the good part was they didn't create a separate branch for Python 3 migration, and therefore they didn't have to deal with merge conflicts later on. They would continuously upgrade it to Python 3. They forbid incompatible dependencies in their CI. They also ran automatic tools for code migration one fix at a time. They had unit tests, and they had gradual rollouts. Here are some slides stolen from Instagram. First of all, they had a timeline, so they actually had a plan to succeed, not some vague idea of a migration. And looking at Jarek, I see that we probably have to finish, right? Okay, so I strongly encourage you to see this talk yourself. It's available on YouTube. This presentation is also going to be available, as well as a link to my GitHub with the examples I was showing and more. To summarize, if you want to migrate to Python 3, have a reason, have tests, and have fun, because willpower is not going to do it. Thank you.